Good morning and welcome everybody to another great Land Effects webinar. I am Jake Lott and we'll be moderating this webinar for you guys today. Want to just go over a couple housekeeping items, things to keep in mind before we get going. Definitely please use the Q&A box in the upper left-hand corner of your screen for any questions that you might have. Definitely use the chat window for any other banter you wish to share amongst yourselves. Definitely going to be talking about some really cool things. If you guys have any type of experience with this stuff and want to share it with the team, just use the chat window for that kind of stuff. And if you want to exit out of that full screen mode, in the upper right hand corner should be a little minimize so you can get out of that. Today we have the privilege of hearing from Ben George, and I'll let him kind of introduce himself a little bit, but we are going to be talking on an introductory level of how to use drones to prepare your site plans. And just a little side note is I was lucky enough to experience some of this stuff that you're going to see today firsthand, because he actually helped create a site plan of my house. And it's just really, really cool, the possibilities and the stuff that's out there these days with technology. And it's just fun to start exploring these different ideas of doing work. So with that, I'll turn the time over to you, Ben.
Thanks, Jake. So hello, everyone. And like Jake said, welcome to the webinar today. So I'm going to be talking to you about drones and about how I've been using drones doing my own design work and how we're using them in the landscape architecture department here at Utah State University. So let me introduce myself. I'm a professor in landscape architecture and environmental planning department at USU. And you can see my research interests listed there at the bottom of the screen: landscape visualization, virtual reality, UAVs or drones, and digital historic interpretation. And these things all, go hand in hand, and I'm really lucky, I guess, in that way. But anyways, about 3 years ago, with the help of some energetic students, I helped to start a drone program in the department, and it's now grown to the point that we have several certified student operators, and we use drones on many, almost all of our student projects now that the students are working on. So this is a pretty exciting topic, and well, at least I hope. But I hope that when we get done, you're going to have the desire to try and implement drones into your workflow. But before you do that, I do want to emphasize that you need to make sure that you familiarize yourself with the legal considerations of operating a drone. In short, if you're going to use a drone for business-related projects, you'll need to have a certified operator to stay within the law. And that sounds scary, but it really isn't that bad of a process. In the work required, it's similar to what it takes to get like a ham radio operator's license. And there's a lot of material, and there's even apps now that you can download that will sort of help you to study and prepare to go take the test administered by the FAA to become certified. So it sounds scary. It's really not that scary, but just make sure that you know what the legal requirements are. All right, so let's set the stage a bit here and talk about the different types of drones that you might work with and why you would select each one. So which drone that you're going to use is really going to largely depend on the size of the site and the context of the site. So a fixed wing drone is suitable to use on larger sites that are in an area that's relatively open, typically something rural, but large suburban areas as well. But if you're mapping a smaller site or an urban site, it's typically much more practical to use a rotor drone like the quadcopter pictured below there, because they can operate in tighter areas and they can provide more precise control to the operator. But they move slower, and so it's going to take you longer to photograph a site. And the other thing, though, to consider is that it's much easier to operate a quadcopter than it is to operate a fixed wing drone. They're a lot more forgiving during flight. So we have 5 drones in our department. They're all quadcopters. That's pretty much what we use exclusively. We've collaborated with Intel on a project where we used a fixed wing drone But for the work of I think most landscape architects, the quadcopter is nearly always going to be the way to go, and they're also significantly cheaper than the fixed wing. So this is predominantly the setup that we use here on our projects. This is a DJI Mavic Pro. It's about $1,000 drone, and it folds up to be about the size of a brick. So it's really compact and portable. You could throw it in a backpack, take it anywhere with you. It has a 4K camera on it, and it's really robust. We have crashed sometimes, but it's a really robust platform. So the software suite then that we use to process the drone captured imagery is Pix4D, and it's a photogrammetry software, and I'll talk a little bit about exactly what photogrammetry is later in the presentation. But and then we have several students, like I said, who are FAA licensed operators, who are the ones that typically operate the drones. Okay, so there's a quick overview of the drones themselves. Let's briefly just touch on why you'd want to use them before we go into things in more detail. So when we first got the drones, we used them specifically to take aerial photos. And using a drone enables you to take crystal clear images of your site in minutes. And of course, that also means that you're going to get great imagery of the current conditions on the site. I'm sure that most of you have probably experienced the frustration of loading up Google Earth to grab imagery of a site only to find out that the imagery is a couple years old, and the site conditions have changed, so I'm going to be honest, we don't actually experience that problem anymore because we use the drones so much that we have the latest site imagery for all of our sites. Then with the photos, and then with the photogrammetry software, you're able to generate contours of your site. And these contours then can be directly imported into CAD or into a 3D modeling program to generate a landform model of your site. Drones can also be used then to capture what a site is like via a video. So you're able to get views that you might otherwise not be able to, and really to provide a lot of information of what it's like to move through a site. So this is a video taken by one of our students showing a park along the Logan River and the surrounding area and how it's sort of all interconnected. And so that's a great tool to use as far as the video function. Similarly, and if I can get this to go to the next slide. There we go. After you've installed a design, you can use a drone then as a marketing tool as well and capture some great footage that showcases your design and the installation. And so this was taken by that same student for a landscaper that wanted to put some videos on their website to share with potential clients. And so hopefully you can really appreciate how appealing this would be as a way of sharing your work. It really conveys the design well, and it lets you just flow and move through the design. So those are some of the benefits that a drone can provide. Let's start to get into the nitty-gritty then of how you actually go about doing some of these things. And I'm going to focus on how to use the drone to capture the aerial imagery and then create a 3D model of a site, and then how you can export that into a modeling program to start designing from it. So, okay, so operating the drone. With most drones, there's going to be two ways to operate it. Either manually with the joysticks and the camera control buttons, or by hooking it up to a smartphone or a tablet and hooking that into the remote, and you control the drone via an app. Now we do both, but prefer, and especially myself sort of being the one who's in charge of the drones, I much prefer that the students use the app to control the drone. And I'll show you why, why that is, starting with the next slide. But in short, there's less that can go wrong typically when you're flying with the app. But if there's a lot of obstacles that we need to avoid on a site, then you need to fly manually because you need to make sure that you're going to maneuver, around these obstacles. The same reason that, flying a plane, the difference between autopilot and manual pilot, basically. So, and quickly, let me add that it is best practice to have two sets of eyes on the drone, one operator who's flying it, and then one person who's acting as the spotter, and they're making sure that there aren't any obstacles or something like that that the operator isn't aware of. So, okay, so we use the Pix4D app, and there's others that you can choose from. But the reason that we favor an app in general is that we're giving the drone a pre-assigned flight path and camera operation instructions, and then we're basically letting it fly itself. And so in the Pix4D app, you can select, there's between 3 different mission types. The single grid mission, it's good for photographing a site if you just want the imagery. The double grid, which is going to fly one grid and then an overlapping grid that's rotated 90 degrees. And that's best for modeling a site. And then the circular mission, which is best for modeling an object, typically. So to show you what these missions would look like, and note that the mission's actually displayed on top of the actual site. So you can build your mission based, by simply visually looking at the map of the site here. But so this is the single grid mission. You can just see it's going back and forth. And then the double grid mission, there's the one grid in white and then the other grid in the black there. And so it's produces a checkered flight pattern. And then the circular mission, where the drone flies in a circle around a central point, but it keeps the drone and the camera focused on the center then of that circle. So then another option that you need to select from is the amount of imagery overlap. And basically, the more overlap that you have, the more frequently the camera takes a picture. And so in the image on the top left, you'll see that the overlap is set to 90%. So 90% of the new image is also visible on the previous image. And on the circular mission, that overlap, it's controlled by how many missions or how many images are taken based on the degrees of a circle. So anyways, I found that on the grid missions, 80% is typically good overlap for your grid mission. It's going to give you a good, reliable model. If there's a lot of complexity on the site, you can go up to 90%. So, and for circular missions, I typically set it between 8 and 10% to get the overlap that we want to make a good model. So, and then the final thing to consider is elevation. So, or the altitude at which you're flying. So the lower you are to the ground, basically, the denser the grid is going to be in order to get good image overlap. So in the upper left-hand corner, you can see that this grid was calculated for 70 feet. And then the one here in the bottom here, this one was done at 150 feet. And it's kind of hard to tell in the imagery, but it's a little bit, the grid is a little bit denser on the 70-foot one than at the 150-foot one. And then the upper right corner here, you can see this one is for 310 feet. And you can see how dramatically different that grid is, right? Now, what altitude you're going to fly at, it's really determined by what you need. But generally, remember that the lower you fly, the better imagery you get. You're going to get more details, but the longer it's going to take to fly. So comparison, the one that's at 70, okay, in the bottom right below the grid, you might be able to make out there, it says that mission will take 16 minutes and 48 seconds to fly, compared to the one at 310 feet is only going to take 3 minutes and 10 seconds. And time's a big thing to consider, because a drone typically has a battery life of around 20 minutes. So you need to plan your missions accordingly. And I typically, we fly between about 100 and 180 feet is the range in which we fly. We still get really good aerial imagery, but it's not, the grid isn't too dense, or it doesn't take as long to fly. So anyways, you have all your missions set up, and then you go ahead and simply upload it to the drone via the remote control connection, and you hit start. And I don't want to make it sound like it's child play, but it is actually remarkably simple. You hit start, the drone takes off, it does its thing, and then it returns to the spot that it took off from, and it waits for you to tell it that it's okay for it to land. And a nice thing though, like about the Pix4D app, is it also keeps a record of all your missions. And so, and if you have an account, it'll actually upload all your files to the cloud, so then you can go retrieve them anywhere. But so I'm able to see exactly the missions that I flew, and I could like reload a mission and fly it again or something like that. So, Jake, I wanted to just pause for a moment here, see if there's any questions that about anything that we've covered thus far that we could address. Otherwise, I'll just keep moving.
No, there's no questions. So
good. I'm
just remind everybody. Oh, I'm getting something in the chat window, guys. Just remember to use the Q&A section if you could as you start typing your questions. But the question was, what's the pricing model of the Pix4D? And I think we're going to kind of cover that at the end, if we can hold that to the end.
Yes. Yeah, we'll cover it. We'll cover that at the end. So,
okay.
Okay. So let's keep moving. So all right. So you've got your imagery. You went out, you flew your drone, and now you have your imagery. So the first thing you want to do really is to make sure that when the images were imported, the orientation stayed consistent. You don't want to have some that are horizontal and some vertical or rotated 180 degrees, things like that. Pix4D is going to figure it out. But I've found that, sometimes the software gets confused by images. So it's just better to just take a moment, make sure that all of your images then are orientated properly. And then once your images are ready, you'll simply launch the Pix4D app and create a new project, right? And this is where then we get into some of the settings you need to make sure that we're doing things correctly so that we get the correct outputs that we want and whatnot. But so the first thing that you're going to need is to select the location of your images. And from a file organization structure, I'd really recommend keep your images organized by project and then by flight, so that if anything goes wrong with images from one flight, it's really easy to figure out which images that was, which flight that was, and so if you need to go refly something or something like that. But anyways, once you load the images up there, if you're using a good drone, it should have already geotagged all your images for you. And so there's going to pull up here. Now there's other ways to go and geotag images after the fact that are not fun, so we're not going to go into that. But it should be noted that even if they're not geotagged, Pix4D can still generate the model. It just doesn't know where on Earth this is, right? And then the scale of the model will not be correct as well. Similarly, then it's going to ask you for the coordinate system, and this should again be automatically generated by the drone. And then it's going to ask you to basically what type of template you want to use. And so you're typically going to use 3D maps, and that's the best for modeling a site. But for smaller sites, say your typical like suburban private residence, creating a 3D model is sometimes a better option, especially if you flew a circular mission. So you load that up, and then it's going to pull up the map and showing the locations of the images here, which are the red dots. And because they were geotagged, Pix4D knows exactly where the site is. And so it can map the location of where all the images were taken. And you can see here, I actually flew 2 missions. There's a double grid mission, that's the bright red dots. And then you can see underneath that, I also flew a circular mission. And those dots are a little bit sort of transparent, red dots there. So anyway, sometimes you'll capture the surrounding areas that you don't necessarily want in the model. And so to save processing time and to not have that in the model, you can actually just draw around the area and say, define this is my processing area, and Pix4D then is going to exclude all the remaining stuff. So, okay, so once you have that in there, it's time to tell it what you're going to do to process it. It's going to ask you what resolution of image you want us to use for processing. And think about this the same way that, you have a 300 DPI image or a 72 DPI image. So the higher the resolution, or the bigger the image that it's working from, the more points that it's going to be able to pick out. And so the more detailed and accurate the model is going to be. Okay, because photogrammetry is a process by which the location of known points in an image, they're identified then across multiple images, and then uses complex mathematical calculations called magic, I think. But anyways, but it's possible to calculate the size and then the shape of an object just based on how those points are moving, you know, in between images. So you want to make sure that you have as many, you know, or the image has as high resolution so it can get as many points, because the more points, the more accurate, etc. So then it's going to also ask you basically the same thing for the point cloud. Again, the larger your image, the more points that it's going to create then as it works with the cloud. And then it's going to ask you if you want to create a textured mesh. And so as you'll get to see later here, it'll export both a point cloud and then a triangulated mesh model. And you can see the export options there at the bottom, PLY, FBX, DSX, DXF, OBJ. So, you know, a lot of options that, standard options, right, that you can bring into most modeling programs. In the third stage then is going to ask you to create, if you want to create a GeoTIFF image. So if you basically want to create, you know, a blended TIFF image, then that's geotagged. And then also you have the option to create the contours. And this is really awesome. You can actually create contours. I believe it's down to 2 inches is like the minimum interval for contours that you can want, or that you could create. And we did do that once, and quickly realized that it's just so over the top that you can't actually use that. But anyways, you can manually set whatever the contour is as you the contour interval that you want, and then that will export that for you in multiple formats as well. So once you have all the settings, you go ahead, you hit start, and the software will start to process all the images. You can keep track of watching and all the lights change, and it's like Christmas, you know, or you can step away from your computer and go do something else while it does its thing. But once it's done processing all the images, it's going to produce a point cloud like you see here. And you can see the photos and the camera locations up on the top here. And then there's the point cloud and the model down below. And we'll spend the rest of the presentation really looking at what that output looks like and how we can integrate it then into our thing. So any questions, Jake, over that portion?
Yeah, we did get a couple.
Okay.
So, and I think you handled actually most of them, but just to confirm, from a ground control points are needed to be able to run this software. It looks like geotagging is the answer. Yes, they should be tagged so we know where they are, but at the same time, you don't need them to be able to create a model. And then also you can actually define the area that you want done.
Right.
Correct?
Yes, you can. Now you can go out and put like ground control points, like, so, you know, you could print out a hash mark on paper and go lay that out in particular intervals. And that actually will help Pix4D then, because it to process things, because it has, you know, a very clear delineated ground point, but it's not necessary to do.
Cool. And then another one was basically, does Pix4D allowed, or is it allowed to be able to take topography and turning it into contours? And it looks like that was an
Yes.
option right
Yep.
there within one of those steps, right?
Yep, it will generate the contours for you automatically. Yep, and we will show you guys that. So,
Yep. Okay, so keep going.
great. All right, so so this is the outputs that we're going to go. We'll look over there. One of these are really the useful ones that you're going to get. So in the next section, then I'm going to talk then about the ability to measure your site using the point cloud. We're going to look at some of the 2D outputs and then talk about the 3D outputs and how you can use those in your workflow. So first, Pix4D lets you measure the distance between between elements in the point cloud, right? So this can be really helpful for not only measuring the distance between elements on the ground plane, but also to measure the heights of elements, you know, as well. But you can see in this example, I'm able then to measure, I forgot to pause this here, but measure this, the side of the house here, and it tells me then that it is 44 feet, which I'll bet that's pretty accurate. Is 44 feet on that on the side of the roof line there. Oops, too far. And then similarly, I can do the same thing with area and volume, right? And so I'm able to just create a polygon. I'm kind of going to skip forward here in the video so you can see, but create a polygon of the around the area that I want to measure. And obviously, if I'm doing this three-dimensionally, it would be a volume thing. And then Pix4D is going to, again, tell me then what the area is, both projected and actually sort of the 3D plane that I drew in space there then as well. All right, then it also creates the photo mosaic of the images that you got from your site. So this is something that you can also, you know, you can do this in Photoshop. You definitely don't need Pix4D, you know, or a panorama creation program like PT GUI, something like that. But to give you an idea of the quality difference between Google Earth imagery and the drone imagery, here's an overlay of some of our drone imagery on top of the corresponding Google Earth imagery. And I don't think that I really need to point out the increased detail. But, you know, some of the really obvious benefits is being able to, you know, make out things like individual plants, and sometimes even being able to tell the species of a plant, and being able to clearly see all the elements that are on the site, you know, such as the irrigation boxes and things like that. So here in video to see, this is what the, let's see here, oh, there we go. This is what the actual point cloud then that Pix4D generates from the imagery. So you can see underneath the eave line there, right, along the house where it was because it was taken overhead, it couldn't actually see then what was under there. And so you have some blank spaces. But this model is really, it's just made up of thousands of points, right? And each one's colored with the color of that point in the imagery that it originally grabbed it from. But you can see it's really made a remarkably accurate model. Oops, too far. And then Pix4D can take that point cloud and extrapolate from the points to then create an actual textured 3D mesh model. And so that's what this is here. And so in this model, we don't have that semi-transparent feel, right, that we got from the point cloud. But you can then see the model then that it's generated. And so again, you know, where on those points where it was under the eaves, it has some problem extrapolating that. And there's ways to, you know, to take additional photos and patch that type of stuff up there. But that's what you can expect to get out of the point cloud and the model processing. So let's talk then about how to integrate some of those outputs into your actual modeling workflow, and really see how that's going to benefit you then. So these are some of the workflows that I use and that we use here in the department. Typically, we're going to take our data from Pix4D and we're going to go into AutoCAD with the contours to create the design then using land effects, right? And then we take it out into our 3D modeling program, whether that's Rhino or Sketchup. And alternatively, though, you can see you can actually take the exported model that's right into SketchUp, right? Or you can actually use, like, so there's Undet for SketchUp there, which is an extension for SketchUp, right? That actually lets you bring the point cloud directly into SketchUp. And then you can rapidly create an exact model using the point cloud as your reference. So I'm going to back up here to this slide. This is actually using point tools, which I don't believe this extension is actually available anymore for SketchUp, but this was the actual point cloud here. And then what they were able to do is they just started modeling basically right on top of the point cloud, and they used the point cloud to create their geometry. and then yeah, and then so they had this very exact, they had all these very exact measurements, and were able to rapidly model and get the exact model of this building here, by using then the point cloud just in SketchUp. But then when you're just using the aerial imagery as a base image on which to render a plan, then you can just take that imagery into Photoshop. You can auto align the layers, and that's going to give you then a quick image of the entire landscape, and then you're able to start just rendering on top of that, bringing in start drawing, or start using that as a base map on which to overlay trace. You guys all know how to design. I don't need to explain it to you, but we use that a lot for the base imagery on our final renderings of plan view imagery and whatnot. And I will say also, I didn't include it here, but it's also a great way to grab oblique imagery. So if you wanted to have some really photorealistic oblique imagery of the site in which to then bring your models in and build them up into the actual context of the site, it's a great way to do that as well. Okay, so to show you a little bit more detailed how that would work. So this is the site that I was showing you that video of, where we were circling it in showing you the point cloud and then the textured mesh. So this is that site, and these are the contours that actually came out of it. So you can clearly make out then in there, let me see if I can turn on this pointer. Here's the house, you can see, but then you can also see it's picked up the trees that are here, some bushes and whatnot. And so there'll always be some things like that where you need to clean things up a little bit. And this is something I didn't go over, but you can actually clean this up in Pix4D by editing the point cloud and removing those elements from it. And so it's sort of one of those things where you have to decide, is it better to do it in Pix4D, or is it easier to do it in Photoshop or in AutoCAD to sort of remove the abnormalities in the contours. But anyways, so that's what you're seeing there. And then you can see then this corresponding image here. So we've taken those contours that have come from the site, right? And then using AutoCAD and land effects, I'm able to start just designing right on top of the existing contours. And I know exactly what my contours are. I know what the site conditions are, and I can just start working with that. And then I'm able to bring these contours now into SketchUp, because they're three-dimensional contours. And so I'm able to generate then the actual landform in SketchUp just using the sandbox tool. And it's also possible, in this one we've used textures, but you can then take that totally spacing it now, but I can take my geotiff image that it's generated, so my aerial imagery that I've captured, and I can actually just overlay that as a texture in SketchUp, so that I have my exact aerial imagery overlaid onto this model as well. And it's really, again, really high resolution. So, but then I'm able to bring in all of the plants and all the models, that I was using in CAD using land effects, and it's able to then generate all of these, on top of the terrain right here inside of SketchUp. And so I think that, this slide here really showcases how beneficial it can be to use a drone to capture the actual contours of your site, exactly what you're working with, to be able to get all that great, imagery, reference imagery and stuff like that, and then bring that all together to quickly create your design in either AutoCAD or in SketchUp using land effects and stuff like that. So, I was going to go over a little bit of other stuff first, but do we have questions at this point, Jake, going over? Because I think these output things are what people are really going to be intrigued by.
Yes, we've got quite a few questions. So
Okay.
let's just take a step back just for a second, and actually going to answer a question from Andrew here. and he's asking what the preferred 3D modeling program is for just everybody listening right now to create those photorealistic visualizations and stuff like that with drone mapping, that whole process. So feel free to like comment, guys, in chat, and I see that starting to happen there, so that's awesome. We've got a couple different ones like Lumion and Shader Light and a couple other ones, but obviously you guys play around with that. I'm going to ask another question here. If we have a larger site and you want to create a really high quality aerial, is it possible to fly multiple flights? So maybe that mission extends past a battery life and it has to come back down.
Yep.
Will it remember where you left off and complete that flight, or how does that whole process work?
Yeah. Okay. So that's going to depend on the drone and on the app you're using. Yes, it will remember, but what we do is we typically fly it in what are termed cells, or you call it missions. But basically, so you're going to have your large area site that you're mapping, and so you're going to basically break it down into missions that haven't, some overlap. They don't need to have a lot of overlap, but they just need to have enough overlap so that it's able to grab. It knows where these things are meeting up. And then you'll fly, mission 1, mission 2, mission 3, mission 4, and so on. Instead of saying, okay, I want you to fly this whole thing, and it's going to take 4 hours to fly this mission. Come back, when its battery is running out or something like that. One of the problems is you're going to burn a lot of battery flying out to the far end to come back. So it'd be really inefficient. And so that's why you break it into just these individual missions. And then you'll combine all of those photos in Pix4D and just tell it to run it. You can actually map or you could model each individual mission and then merge those in Pix4D. But it's easier to just take all of your photos and put them into the same project file and run it. So we had this project that's up on at Powder Mountain. It's a ski resort here in Utah, and that was 6,000 images, I believe. It was roughly 500 acres, and that was about I think it was about 20 to 25 missions, individual missions that we flew, and then we just combined all of the photos together and had it run it. So typically you want to keep your settings the same as much as possible. So like don't have one where it's flying at 300 feet and another one where it's flying at 100 feet. Just keep your settings the same so it's consistent. But that's how you would partition a large site to do it.
Awesome. That works out really well. Another one, they're wondering if they can use drones to create a legal site survey, and if so, what's the process or requirements for that?
Yep. So as far as I know, you can't use them to create a legal survey. So the accuracy, I'll mention this actually on the next slide. The accuracy is 2 centimeters, which is 3/4 of an inch, right? And now I'm not sure what the legal or what the accuracy is of an, when you hire a surveyor to come out. It's probably pretty comparable, but from a legal framework, at least in the state of Utah, you have to have an actual surveyor. Now, I don't know if like a surveyor could fly with the drone and then, he's able to put his stamp on it. That might be allowable. So if you had a surveyor's, you can stamp it as a surveyor, then it might be permissible, but I'm not sure on the legality of that. That's something you'd have to dig into deeper.
Okay, cool. Another one. What is the preferred? Oh wait, just joking. I already read that one. They're wondering if you've tried other mapping software, and I know we're going to get into that a little bit. But Maps Made Easy, Drone Deploy,
Mm-hmm.
Stuff like that. So and another person's asking Pix4D versus drone deploy. So maybe we can leave those to the end. We'll
Yep.
just keep those on the back there. And then somewhat important one here is, what's the level of processing capacity or power does your computer
Oh,
need
yeah.
to do those things?
Yeah, I mean, so we um, we have we have a really powerful computer, but we were running it on a computer that basically, what I'd say is, we bought a computer that was capable of running VR. And I think I paid $1,500 for it at the time. And this is about a 2-year-old computer. And we've been running it on there, as well as on the more powerful one. And ultimately, it's going to just come down to processing time. Unless you're working on a enormous site, it's going to process it, and it's just going to take longer to do it. But so, say like, let's say a typical site of maybe like a 5-acre site that has 100 images that you're going to be processing. And if you process that at full or maybe a little bit below full resolution, it's gonna go through everything, generate the point cloud, the model, and the contours, probably in about an hour and a half to 2 hours. And then the GeoTIFF, right, that's merging all of the images, that actually is the most time-consuming process. And so a lot of times we'll do that actually, or we can do that outside in Photoshop, which might do it a bit faster. But for getting the model in the point cloud, that's about a good frame of reference, with I'd say a powerful computer, but not ridiculously powerful. If you're running Lumion, if you're running Lumion or 3ds Max, then your computer is almost certainly going to be powerful enough to process this.
Cool. So we have a few more questions that I want to leave to the end. So why don't you go ahead and just keep going, and we'll touch bases in a bit.
Okay. So so let's just then recap the benefits. So using the drone in Pix4D, you're going to get a really highly accurate model of your site. Like I said, 2 centimeters. So obviously, I'd encourage you to take some measurements on the site to do some ground truthing, but we found it's been consistently right around that accuracy measurement there. So then you get really high resolution imagery that gives you a great overhead view. And the drone can then also be used to, like I said, give you some great oblique imagery into your site. And that's the one thing that I didn't mention here, actually, I'm just thinking about, is that it's also, if you're proposing elements that are quite high, say like a viewing platform, I mean, that's a great thing where a drone can just quickly fly up to give you an accurate imagery, right, of like what the height is that the viewer might be at. You want to know, what's my landscape going to look like when the viewer's at this, 3-story window. You can just fly the drone up to that height, and you know exactly what the view would be like looking down. And then you get the 3D model and the point cloud that you can take and import directly into your 3D modeling program to start working with that, which is really a great time saver as far as creating the model. Again, you're not going to get this really polished, perfectly polished model, but it provides an excellent framework around which you can really quickly just create a highly accurate model. And then it's finally also going to generate, we didn't go over it here, but you can generate a DEM. So if you work with doing a large site, you want to take your information in a GIS to work with, something like that, DEMs can also then be exported. So let's talk about where the rubber hits the road. And all of you probably like see the price tag here and are like, so we use Pix4D because they have an educational version that is considerably cheaper. So we have also used Aggiesoft PhotoScan. We haven't used Drone Deploy that I'm aware of, but we have looked at it. But there's a lot of different options out there at a lot of different levels of cost. In experimenting with the different software, I I do really feel like it's kind of you get what you paid for. And so you kind of have to figure out how much detail and accuracy do I need, and you know, and if and you pay for the level that you need, basically, right? Now, if you're really interested in trying this, I'd recommend getting some of the free software, or most of the paid software has a trial version, you know, that you can use, and then see if it's something that you think is really going to benefit you. Honestly, I think that just the aerial imagery itself makes having a drone worth it. Even if you aren't going to use it, you know, to generate a model of the site, you just want it for the imagery. I think that's really beneficial. Then as well, there's some apps here that I put at the bottom that we didn't really go over. We went over the control of the app, but this software actually then is for other things. So Hanger 360 lets you create 360 panos at any spot, which is really cool to give somebody an overview of what it you know, of what it feels like to be on a site. So if somebody maybe couldn't see the site, you're able to fly some panoramas at a couple spots to give them a feel for that. The DJI Ground Station Pro, that's the control app for that DJI has. And then Autopilot is, especially this one's really for videography and photography. So if you wanted to get really slick, beautiful imagery, it's a great app. I do it on like an iPad on a tablet, so you have a bit more real estate that you're looking at, but it's a great app for controlling things like that. So yeah, so that really, I think, wraps up everything that I wanted to share with you guys. So it looks like we have, you know, about 10-15 minutes left for questions. Jake, what other questions did you say people had?
All right. So just a reminder, guys, bring in those questions at this time if you do have them. But we'll start with a little bit more of an operation thing. And I'm assuming it's going to be something that you would really cover as you get licensed to be a drone operator, but how you actually compensate for wind.
Yeah, so okay, all of these drones, well, this is where, again, it gets into either I'm flying manually or I'm flying with an app. So you know, if you're flying manually, you'll constantly sort of be having to adjust, right, for the wind blowing. If it's flying with the app, it knows that I need to stay on this, you know, at this this flight plan using GPS, and so it just automatically adjusts. And you'll see we've flown a lot of sites. If any of you are familiar with where USU is, we're in this mountain valley, and we're right in front of a canyon, and so we get a lot of wind that comes out. And when we fly with the app, even with the gusting wind, you'll see the drone struggling to stay on course, but it stays on course. It automatically, you know, just adjusts for it itself. If you're getting over, what is it for a fixed wing drone? I believe it's over 30 knots. If the winds are over 30 knots, that's when you shouldn't fly a fixed wing drone. And I'd say we've never flown one of our quadcopters, you know, in wind speeds faster than that. But the app will automatically adjust for it. As far as if you're just doing the aerial sort of like, you know, capture of imagery to put into a photogrammetry software, it's not going to matter. If the drone got pushed off a couple inches this way or that, that's not going to matter. What will matter is that it will take up more battery because the drone is having to, you know, adjust more, put more power into certain propellers, things like that. Yeah, that's how you do it. If you're, you know, the bigger problem would be if you're trying to do videography or something like that, and then that'd be something that, you know, you're just like, well, it's too windy to keep the drone stable to get the, you know, the footage that we want. Most drones, you know, it's not big enough to put like a stabilizer, a steady cam gimbal on there or something like that. And so that's something you could either try and do in post-processing, but I'd say if you're videoing, you need to have it be relatively more calm.
Cool. So another one here. Are there any drone choices that might be a little less expensive? So obviously there are so many drones out there.
Yeah. Yeah, I can't talk to all of them. There's like the GoPro Parrot, which I want to say is 600, but I could be totally wrong on that. There's lots that cost more, but yeah, there are several different options. What's gonna what's gonna impact it as you get into the cheaper ones is that you're sacrificing features, like you can't interface with an app, for instance, or the camera is not as high a quality, um, something like that. So, or the build quality isn't as good. You can build a drone if you're really um, really technical. You can build a drone. There's plenty of instructions on the internet, and the parts are readily available, or you can 3D print parts, etc., for quite a bit cheaper. But obviously, you need to have the technical skill to do that. And I'd say, the prices for these things are only going to come down. Where they were, the DJI Mavic that we have, that's $1,000. Before we were buying $3,000 or $4,000 drones. So, and now 2 years later, it's $1,000 drone. So prices are as well going to come down.
Yep, and that's what people are saying in the chat box. There is once they release the new model, then the other ones go down. So,
Yeah, yeah, as well, right.
and just keep in mind, just like the software itself, you get what you pay for. So, um, there's all kinds of things out there, but you will start to limit yourself on what options it has and what the features do and stuff like that as you go cheaper, for sure. So just do your research, I guess. So now for a couple interesting ones here. The point cloud, for the point cloud itself, can
Yeah.
AutoCAD read it specifically, or do you need Civil 3D, or is it strictly that is in Pix 4D?
No, so you can export the point cloud. I know you can bring it into SketchUp, but I will be honest, I've never tried to bring it into AutoCAD. So I can't say, I don't want to say one way or the other that yes, that is or is not possible. You can bring it into like other point cloud readers, but I'm not 100% sure. I think that'd be something that a quick Google search could probably verify one way or the other.
Cool. So how much time is typically spent for actually manually processing the data, like modifying the contour lines and 3D model stuff?
Oh, well, obviously it's going to depend on the size of the site, right? But so let's go back to kind of like that, like a 10-acre 150 image site, or 5-acre 150 image site, something like that. Yeah, typically you could extrapolate or take out, like trees or bushes or whatever, and so that it can extrapolate over and through those types of things. It's pretty quick. Honestly, I'd probably do most of that. Typically we do most of that in Pix 4D. And it's really a process of, I guess the best way to describe it is if you're using a 3D modeling program and you just rotate around and select different points and delete them. Or you don't delete them, but you tell them to exclude it, right? And then what you'll do is you'll process the contours at that point. Then, instead of processing them from the beginning, you'll process, make the point cloud, clean up the point cloud, and process the contours. So I would say that for a site 5-10 acres, you're not going to spend more than like half an hour doing that. I mean, you could get really, really tedious and whatnot, but yeah, it's pretty painless to do.
Cool. All right, so this is more of a how Pix 4D or other software run. You're running it on the Mac side of things?
Nope. We're
It's
running it
on Windows?
on Windows. So Aggiesoft, if we go back to this slide, Aggiesoft has a Mac version that you can use, and I think that Aggiesoft is pretty good. I think, well, it's very good. So, but we went with Pix4D because Pix4D had the educational version that we could use. So, but yeah, if you Google, if you Google like just photogrammetry software options, at the top of the list somewhere, there should be a link to a Wikipedia article that actually has a huge matrix of seriously like 60 options of all this photogrammetry software, and it will tell you how much it costs. It'll tell you, what type of outputs it can do. It'll tell you what operating platforms it's on and available, and everything like that. And so that's something that, it's good to go through, and then it has links to the website so you can go and check those out individually.
Cool. All right. So now getting into the certified a little bit, I know we're running a little close to the time here. So how much time and money is invested to get certified typically?
Okay, well, so now you're pushing my boundary because I am actually not certified because I don't have to be. Um, but it is, and that gets into, again, the legal requirements of whatnot. I believe it's $300 to sit the test. Our students take a class that's offered by our aviation department that they do. It's a 1-semester class, and I mean all of the class does not focus on that. They build a drone in there. They go over all sorts of other things like that. Like I said, I've had several people tell me that it's akin to taking the ham operator's license. So basically I study for a month, and I go sit the test. So, and there's apps that you can download, or there are books that you can get. So I just Googled really fast. It's $150 to take the test, to be an operator. And you're an operator, you're not a pilot. So,
and Kevin is actually saying in the chat there that it's right around that $100 range, and he used a remotepilot101.com to learn stuff, and made it super easy. 2 weeks for stuff and all good. So yeah, there's definitely some good resources out there.
And last time I talked with the professor who teaches the aviation course, he said that they had 100% pass rate. So it's really basically, what they're teaching you is they want to make sure you're not going to fly the drone especially into some situation where you're endangering, air traffic, commercial and private air traffic, and whatnot. So it's not, I don't think it's that difficult to do.
Cool. All right. I think we have time for like 2 more questions here. So just a side note, people are definitely interested in seeing some of those images from the Powder Mountain project.
Oh, yeah.
So maybe we can share that offline, and then kind of post that or link a few photos to our recorded version of this.
Okay.
So we'll work offline with that if that's cool. So yeah, that's always interesting to see. So, and then in your experience, the interference from power lines to other utilities when filing manually, is there a big interference with that kind of stuff, or
no?
Doesn't affect anything, just as long as you don't run into them, right?
Yeah. And don't run into them.
Yeah,
just leave it at
good.
That.
That's an expensive drone.
Yeah, no interference.
Cool.
That we've encountered, and we've operated around like the big transmission lines.
Cool.
And haven't had any interference.
Cool. And then I'm not sure what this is, but Kevin's asking if you use ND filters at all.
No.
Can you clarify what an ND filter is for us?
Because we don't use it. So
well,
so that's why I was able to say no, we don't.
Okay, well then that's good, Kevin. If you want to explain what those are, that'd be great. If not,
if he's talking, I'm assuming he's talking about
neutral density filter.
Okay, yeah, for on the camera lens itself.
Yep.
No, we don't. Which actually could be, no, we don't use any filters on it, and that's going to be, again, something to consider with your drone purchase, because some drones let you swap out, like the sensor package, whether you're using a camera or you're using, like a LiDAR package or something, or to adjust the actual camera that you're putting in front. And other ones, it's a built-in camera and it's proprietary and it doesn't have as many options of things that you can hook up to it, stuff like that.
All right, cool.
But yeah, we don't use filters on our cameras.
Okay, last one, because we have like 30 seconds left. They're wondering if the FAA license is nationwide, or do you have to do it for individual states?
Oh no, it's nationwide.
Cool.
Yep.
There you go.
Yeah,
Nationwide.
and I believe the FAA has certified locations that you have to go take that out. Like for instance, we have to go take it at our airport, but I believe that you can take it at other testing centers that are just certified as well.
Awesome. Well, awesome. Thanks, Ben. Thank you guys for all the comments and stuff. It made it really, really good. Hope you guys learned a little bit about this and kind of sparked that interest in kind of bumping up what you guys do. And if you have any more questions or anything that you want to share after the fact, we're here for you at landeffects.com. Send us in a ticket and we can kind of communicate via that way. But otherwise, have a great weekend.
Thanks, everybody.